Alright guys, this lesson is going to be looking at division and how division works with our index laws. A few lessons ago, we looked at doing our basic multiplying and dividing with algebra and how they worked. We're going now to start to extend that with what happens with integers in algebra, what happens when we have higher powers like 2 to the power of 8 and 2 to the power of 12 and x to the power of 15. How do they work together when we're doing dividing? And that's what this lesson's about. Our last lesson before this one, we looked at multiplying numbers with different powers, and we looked at the pattern there. And the pattern we found when we multiplied numbers with different multiplied algebra with different powers, but it's the same letter or the same number at the base. The shortcut was we added the powers. So when we multiplied numbers with the same base, we added their powers. Well, because division is the opposite of multiplication, when we divide numbers with the same base, we subtract their powers. So this lesson, the pattern that mathematicians discovered when they played around this was the shortcut was, well, we can subtract powers when our bases were the same. The other thing to highlight here, it's okay to get a negative answer as our power. That's perfectly normal because when we're doing takeaway, we can go past 0 when we do takeaway, so it's okay to get negative answers. And the other thing is the order in which we do our takeaway is important. We read from left to right. So if we have a look, the rule says that when I'm dividing numbers with the same base, we subtract our powers. So A and A is the same base. So what we end up doing is we take away their powers. So that's the official algebraic description of the rule. Remembering also that we have another way of writing division, and that is we can write fractions. And fractions are just another way of, like I said, writing a division. And because it's division, if we have the same bases in our fractions, we subtract their powers. So let's jump in and look at some examples. So example 1, the first off, it says, simplify the following, leaving your answer in index form. Now that word is very important. Index form means I want my answer to have the same base as the question. So I want it to have a base and it needs to be left with a power. All right. So let's jump in and look at that. Remembering index form means it must have the same base as the question. So if we have a look here, leaving my answer in index form, my base was a base 2, so my answer must have a base 2. Now when we look at this and my bases were the same, I'm dividing numbers with the same base, so I'm going to subtract their powers. So that's just going to be 9 take away 4. So the answer to this one in index form is 2 to the power of 5. That's my answer in index form. Looking at example 2. Example 2 is a fraction. And we know fractions are just another way of writing division. So this one here, if I wanted to, I could write it as 5 to the power of 12 divided by 5 to the power of 3. And I know 5 to the power of 12 divided by 5 to the power of 3, they're the same base. So I'm going to subtract their powers, and 12 take away 3 is 9. So this one becomes 5 to the power of 9. Notice that my base is the same base that was in the question. So I've left my answer in index form because there's a base and there's a power. Let's start to extend that idea with some algebra. So if I look at example 3 here, and example 3 says I have y to the power of 8 divided by y to the power of 12. Well, my base is the same, so what we're going to end up doing is we just take away our powers. And we do it, remember, we read it in the order. So whatever we start off with on the left side of the equation, we do the takeaway in order. So we're going to do 8 take away 12 And here's a time where we're going to get a negative answer. And it's okay to get a negative answer as our powers. So y to the 8 divided by y to the 12 ends up being y to the negative 4. In example 4, now previously when we did a fraction, if I go back up, I rewrote my fraction as a division. It's something I really want to avoid doing, writing it as a division when there's algebra involved. So when I come here and example 4, I'm going to avoid writing that as a division. I'm going to keep it as a fraction. When I do these types of fractions and a division with algebra, remember we divide the numbers first. So if you're not sure, you get your calculator out and you do 15 over 5 on your calculator. And when you do 15 divided by 5 or 15 over 5, your calculator is going to spit out the number 3. And if it's just the number 3, remember its denominator is always 1 as well. So if I write just over here on the side, 15 over 5, if I've typed that on my calculator is going to give me a response of 3, but I know any whole number can be written as a fraction by making its denominator just the number 1. And the reason that I've done that is because there's still some algebra left over in this question, and that algebra might end up in the numerator, it might end up in the denominator. We just have to see how it plays out. So now we're up to looking at the b's. Well, they're the same base, so I'm going to take away their powers. We're going to do a 10 and take away 7, so we know the difference between 10 and 7 is 3. But the thing is, the highest power was at the bottom. So the difference between 10 and 7 is 3, so there's going to be b to the power of 3 left over. And that answer, b to the power of 3, is left in our denominator. So that's a slightly trickier example, and we're going to say our answer is 3 over b to the power of 3. So we just got to be careful with this one, and I'll slowly go through it again. Step 1, divide the numbers, 15 over 5. Do that on our calculator. If our calculator gives us a whole number as an answer, remember that the denominator is 1. That's where 3 over 1 came from. After we've done that, we look at the algebra, and b to the power of 10 and b to the power of 7 are the same bases. So we want to subtract the powers of numbers with the same base with division. Well, the difference between 10 and 7, subtraction, is 3. So we know our answer's got to be something to do with b to the power of 3. And in fraction format, the most b's, the highest powered b, was at the bottom. So b to the power of 3 goes to the bottom, goes to the denominator. And that's where we get our answer of 3 over b to the power of 3 from. Example 5, if I look at this one, and I'll just do that. Fractions act as grouping symbols. So with a fraction, you've got to do all of the numerator, you've got to do all of the denominator, and then you worry about what's going on. So if I look at the numerator, in the numerator, these two, they've got the same base. So numbers with the same base, I add their powers. So my numerator becomes x to the power of 13. When I now look at the denominator, there was nothing else to do in the denominator. That remains x to the power of 3. Now that's just a division, and we know with division, we subtract our powers. We don't have to worry about any numbers, because remember there are invisible 1s written in the front of those numbers, and they don't really matter because 1 divided by 1 is going to be 1. So we ignore the number part out the front and we just subtract our powers. And 13 take away 3, the difference between that is going to be x to the power of 10. And we leave this one as x to the power of 10. If we wanted to, we know it's x to the power of 10 over 1 because there's nothing left in the denominator except that invisible 1, but we don't have to write it. So we leave our answer as just x to the power of 10. Example 6, I've changed the word in this question. The word in this question now says evaluate, which just means I want to know what its value is. I want to know what its number is. And I can make my life easier by doing my index laws first. So I'm looking at this and answering this one. I can see I've got the same base. And because I have the same base, I subtract my powers. 6 take away 4 is 2. So if I was to write this out, I would rewrite it as 3 to the power of 2. Remembering, I call that index form. Now, I've got my answer. It's 3 to the power of 2. That's index form. But the question says, find the value of. Well, 3 squared is just 3 times 3. And I know 3 times 3 is 9. So when I evaluate 3 to the power 6 divided by 3 to the power 4, I get the answer of 9. Another way that this sometimes gets called is that it's basic numeral. A basic numeral, the word numeral being number. So evaluate, basic numeral means just write the number. I'm not worrying about the index part.